Let's say you have this cuboid-shaped box placed on the table. Try pushing it a little. You will require some force to push it forward. Now place this same box on top of cylindrical-shaped pencils and push it. What do you notice? You will notice that the force required by you to push it to the same point as before will be lesser. Why is that? Do the pencils reduce the friction between the box and the table? Absolutely. But it's not about the pencils, it's about the shape of the pencils. They are cylindrical. Assume you are traveling to another city and you are carrying luggage weighing around 25 kilograms. If you're unable to carry the bag, the only option you have is to drag it on the floor. But you will still require a lot of effort to drag your bag. But what if your luggage had wheels under it? Won't it be far easier to carry it around? Yes, it'll be easier. But the question is why? Why is it easier to roll a box over cylindrical pencils relative to pushing it on a flat surface? Why is it easier to carry the bag around when it has rollers under it? Hold on to this thought. I'll come back to it. Before we discuss the above situations, we need to understand what sliding friction is. The concept is simple. It is the frictional force which opposes the relative sliding motion between the two surfaces in contact. What does this mean in simple words? It simply means that if an object is in motion on a surface, the frictional force that is offered by the surface is called the sliding friction. The key words here are sliding motion. The two surfaces have to be in relative motion with each other. In our example, when a box is moving on the table, we say that the box is in relative motion with the table. The resistive force applied by the table when the box is moving is called sliding friction. Remember, the objects have to be in relative motion. Because there's movement involved, this force is also called kinetic friction. Now consider the example of the luggage in which we don't have the wheels under it. When we move the luggage, what will the resistive force applied by the ground be called? Yes, sliding friction. But what happens when we attach circular wheels at the bottom of the luggage? Yes, the friction gets reduced to a great extent. This type of friction which arises when an object is rolled on a surface is called rolling friction. It is a force associated with rotational movement. Now can you tell me by pure intuition about which force will be lesser? Sliding friction or rolling friction? Yes, rolling friction is usually lesser than the one associated with sliding friction. And that's why attaching wheels at the bottom makes it easier to move the object around. And similarly, moving the box on top of the cylindrical pencils is also easier. Can you think of more examples where the concept of rolling friction is used to reduce the friction? Yes, tires of your car. When the car is in motion, the ground applies a force of resistance which is nothing but rolling friction on the tires. Do you remember seeing ball bearings? They are spherical metal balls used in many mechanical structures which have moving parts. They're generally made up of stainless steel, brass or ceramic. They reduce friction to a great extent, which in turn reduces the wear and tear of machine parts. So we got the concept of sliding and rolling friction. There is another interesting type of friction which we need to know about. Will the force of friction come into play only when the two things are in relative motion? Not necessarily. To know which kind of friction I'm talking about, watch our next video.